Okay, so to graph this polynomial function, we really just need a couple of things. We need to know the degree of the function so that we know what its end behavior is doing, and we need to know where the x and y intercepts are. So if I were to FOIL this all together, which I don't want to do, but if I were to FOIL this all together, I'd have x times x times x times x, which would be x to the fourth. If there was a 3 right in there, I'd have 3x times x times x times x, which would be 3x to the fourth. The coefficient only matters for if it's positive or negative, so that we know if it's been vertically reflected or not. But in this one, this degree would be x to the fourth. X to the fourth is important because if the degree is even, then the arms are going to be both up, the end behavior. If there was a negative leading coefficient, whatever number that would be, it would just flip that and both arms would be down. And all the squigglies would be going on in between. If the degree happened to be odd, the default arms start down and end up with the squigglies in between. And then if it had a negative leading coefficient, that would flip upside down. It would start up and then down and down with the squigglies in between. But in this case, we have the even degree with an invisible one leading coefficient, so I know the arms on this graph are going to be both up. Alright, degree is one important thing. Then we've just got the x and y intercepts to worry about. This whole table is about x-intercepts, that's what zeros means. So if I look at this function, each of these pieces in here is going to give me a 0. This will give me x equals 0. This will give me x equals 3, and so will this one. And this one will give me x equals negative 2. So down here in this table, I've got a 0 at 0, 0 at 3, and a 0 at negative 2. Multiplicity is ridiculously important. Multiplicity means how many times that 0 showed up. So this 0 only showed up once. This 0 showed up twice. And this 0 showed up once. Normally you would see a problem like this written not with 2x minus 3's, but with x minus 3 squared. And normally if the problem looked like this, the multiplicity is instantly recognizable by what the exponent is. So the 3 came from this factor with this exponent, its multiplicity is 2. The 0 came from this factor, its invisible exponent is 1, its multiplicity is 1. The negative 2 came from this factor, its invisible exponent is 1, its multiplicity is 1. The multiplicity tells us whether at that x-intercept the graph will cross through the x-axis or just touch and bounce off. If it is even, it's going to touch and bounce off. If it's odd, it will cross through. So now that we've got that table filled out, we should be almost ready to graph this. Normally we would need to find the y-intercept as well. It says find the x and y-intercepts. In this problem, because we've got an x-intercept of 0, that takes up our y-intercept. And we've got one at 3, we got one at negative 2. If we had to find that, if we had to find the y-intercept, to find a y-intercept you change x to 0. So we would go 0 times 0 minus 3 squared times 0 plus 2, and we would just calculate out what that equals, and it's going to equal 0 this time, but it would just look like this. We'd have 0 times 9 times 2, and if this wasn't 0, we would just work down and get a number, but it's 0 in this case. Alright, so to graph this, I just need to make sure that my arms and my touch or bounce and cross and my intercepts all line up. So let me get those out of the way, and if this graph has to start with an arm up and then come down and touch this intercept or cross it, let's see which one, cross. It's going to cross through, and then eventually it's going to have to turn and come back up. This one, the 0, 0, it's going to also cross through, and then it gets to the 3 intercept, so it's going to eventually turn back, get to this 3 intercept, where it's only going to touch and bounce off, so it will probably look a little more like this. Touch and bounce off, and now I've got the end behavior how I want it, and I've got the intercepts with their proper cross or touching. So the way I would grade a question like this is not so much, I'm not going to care if it's like somebody else's problem looks like this and yours looks like the first one. It's not really a 1050 topic of where these local max and mins are. We'll get to find that in a calculus class, but this is just a sketch, and so I am happy if the end behavior is in the right direction, if the intercepts are in the right places, and if the graph crosses or touches properly. So this one needs to cross through, this one needs to cross through, this one needs to bounce off. And as long as it's that shape, facing that direction, with these behaviors, I am going to be happy.